Hello everyone, I hope you're doing well. Since it's such a nice day out, I thought I'd record this lesson outside. So what you see behind me is the canal near Charles River. I'm here in Cambridge, Massachusetts. For this lesson, you'll need your notebook. If you don't have your notebook, you may use a sheet of paper, or you may write notes on the margin of page 56 of your textbook. Remember that a proportion is a situation where two fractions are equal. My favorite example of a proportion is the equation 3/4 is equal to 6/8. So let's write that down. 3/4 is equal to 6/8. These are two different fractions, but they represent the same number. But how do we know that the proportion is true? That is, whether the fractions are equal. You can transform the model representing 3/4 by drawing a line through it, showing that it is actually equal to 6/8. How you would do it is something like this. So if I drew a rectangle, it's like this, divided it into 4, and shaded 3 of them, this would stand for 3/4. However, all I need to do is to draw a line across it like this, and it gets transformed into a model for 6/8, because now there are 8 pieces total, and 6 of them are shaded. So this shows that 3/4 is equal to 6/8. However, when working with proportions during an assessment or in a real-world situation, it may be more convenient to use cross-multiplying to check whether a proportion is true or whether two fractions are equal. To cross-multiply, multiply the top of one fraction by the bottom of the other fraction, then go vice versa. Multiply the bottom of the first fraction by the top of the second. If the two products are the same, then we have a proportion. For example, notice that 3 times 8 is equal to 24. And also, 6 times 4 is equal to 24. So since the products match, then the proportion is true. Now it's your turn. Are the following proportions true? So the first proportion is 2/5 is equal to 3/10. And the second proportion I want you to check is 4/6 is equal to 6/9. At this point, maybe we should pause the video and see how you guys do. And then after the pause, we'll go over cross-multiplying both of these. You should discover that the first proportion is false, since 2 times 10, which is 20, is not equal to 3 times 5, which is 15. So this is not a proportion. In other words, they're not equal. However, the second proportion is true, since 4 times 9 is equal to 6 times 6. This leads to an important fact about math, which I will explain at the end of this video. Now, it can happen that one of the numbers is unknown or replaced with a variable. In that case, it should still be possible to figure out what the unknown value is. When we find an unknown value that makes a true statement, this is called solving. So this is what's called solving. So for the proportion 3/4 is equal to x/8, if we can find out what value of x will fit on top of 8, then we will have solved it. Perhaps you remember the fractions from before, so you instantly know that this needs to be 6. Or, in other words, that 6 is the solution to this proportion. It turns out that cross-multiplying will also work in solving a proportion. Let's try it. Cross-multiplying yields 3 times 8, which gives you 24, is equal to x times 4. In other words, 4x. Let's rewrite that on the top side here, so we could check out what that does. So, according to the cross multiplying, 4x is equal to 24. Dividing 24 by 4 gives 6, which is the solution to the proportion. Let's look at a real-world situation like the one that we have over here. If 3 bananas cost $2.25, how much would it cost to buy 5 bananas? This can be rewritten as the proportion 225 over 3 bananas is equal to x over 5 bananas. Back in section 1.1, we saw that you can answer this question by getting the unit rate first, then multiplying by the number of bananas required. So the unit rate is 225 divided by 3. Let's use a calculator. 225 divided by 3. Divided by 3, which gives me 0.75. Since we need 5 bananas, we will need to multiply this unit rate by 5. Times 5, which gives me 375. With cross multiplying, we have a shortcut, because now we don't need to find the unit rate. Let's see how that works. Take our proportion over here. Just multiply the top of one fraction with the bottom of the other, and vice versa. What that leads to is the equation. What that leads to is the equation 225 times 5 is equal to 3x. Okay, now 225 times 5 is 1125. Is equal to 3x, and then dividing this number by 3 would yield 375. The solution is $3.75, which means that 5 bananas would cost $3.75. Now it's your turn. Read example 1 on page 56 and try to got it problems A, B, and C on the bottom of the page. Good morning again. This time I want to talk to you about the equation of a proportional relationship. This is still in section 1.6 of your book, and this will cover the examples on pages 57 and 58. You might remember a table of a relationship between the number of days and the height of a certain plant. On day 1, it was 4 centimeters high. On day 2, it was 8 centimeters high. On day 3, it was 12 centimeters high. And on day 4, it was 16 centimeters high. You may also remember that this relationship was proportional. If you divide any height by its corresponding day, you always get the same answer, which in this case was 4. 16 divided by 4 is 4, 12 divided by 3 is 4, and so on. I want to point out two things about this number 4. First, notice that it is next to the 1 on the table. This means that 4 is the unit rate of this proportional relationship. If you know that a certain relationship is proportional, then the number on the right related to 1 on the left will automatically be the unit rate. The unit rate is important in the problem. In this problem, the 4 denotes how fast the plant grows. It grows 4 centimeters per day. The second fun fact about 4 is that this number completely determines the relationship. If I know the day, then I multiply that number by 4 to get the height. So, if the experiment ran for a 5th day, our best prediction for the height of the plant would be 5 times 4, or 20 centimeters. Now, our prediction would only turn out to be correct if the relationship is truly proportional. And it probably isn't, because plants don't keep growing at the same rate they do when they first germinate. What we're saying is that if it were proportional, then our best guess is that on the 5th day, it would be 20 centimeters high. Since 4 completely determines the relationship, there is a more compact way of representing it. If the day is replaced by the letter D, and the height is replaced by the letter H, then the equation H is equal to 4D represents the same relationship as before. H equals 4D just means that if you know the day, then multiply it by 4 to get the height. Make sure you know how these symbols interact with each other. As an example, if D were 10, then H would be 10 times 4, which would be 40. If D were 12, then H would be 48, and so on and so forth. You can generate as many table rows as you want given the formula H equals 4D, which makes this equation very handy. Let's see another example of a proportional relationship. You might remember in a previous problem that 3 bananas cost $2.25. We found that the unit rate was 75 cents per banana. Instead of making a table, we can represent this relationship with an equation. If B stands for the number of bananas, and C stands for the cost, then we can say that C is equal to 0.75 B. That is, if you know the number of bananas you want to buy, multiply that number by 75 cents to get the total cost. In particular, if B were 5, then C would be 5 times 0.75. Or 375, which should sound familiar as well. Lastly, let's see an example of an equation for a common type of non-proportional relationship. Suppose that each slice of pizza costs $2, but the pizza box is not free. It costs $1. But it can fit up to 8 slices of pizza. The situation would give rise to a table like this. One slice would cost $3, 2 slices would cost $5, 3 slices would cost $7, and 4 slices would cost $7. What equation would fit this situation? The unit rate of the cost of each slice of pizza is $2. So it would make sense that P, the number of pizza slices, should be multiplied by 2. But since you're also paying $1 for the box, you'd have to add $1 to this value. That means that the equation should be something like 2p plus 1. 2 because each slice of pizza is worth $2, and plus 1 for the box. The equation turns out to be C equals 2p plus 1. Since there is a plus operation, the unit rate of 2 does not completely determine the relationship, and therefore this relationship is not proportional. I hope these examples allow you to understand better the examples on pages 57 and 58. If you have any questions, please do not hesitate to ask on Google Classroom, or feel free to email me. Now, for the notion I promised to bring up at the end of the video. You can see that mathematics does not stop you from saying things that are false. Earlier, I said that 2 over 5 is equal to 3 over 10, which is not true. In other words, you can lie using mathematics. This is why it is so important to also know how math works, so you can determine the truth or falsehood of statements other people make. In that example, we were able to use cross-multiplying to see that 2 over 5 is actually not equal to 3 over 10. So watch out. Remember that if you don't use math, then math will be used against you. It pays to pay attention. Thank you again for your attention and participation, and may God bless all of you. I'll be seeing you pretty soon.